Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Student, in this video, we have question number 11, NEET Physics paper 2015. Student, let us solve the next question number 11. The electric field in a region, certain region, is acting radially outward. In a certain region, the electric field is acting radially outward and is given by the equation radially outward in all directions. This is electric field E and is given by AR radially outward in all directions. So it is in space. It's like as if this electric field is originating from a point charge. So it is in all radiating into the space. A charge contained in a sphere of radius A, a charge contained in a sphere of radius A, centered at the origin of the field. If I have a charge contained in a sphere of radius A, if I draw a sphere of radius equal to A, radius A, centered at the origin. Charge is contained in a sphere of radius A, so the charge is here, centered at the origin of the field. Suppose the charge is Q. Origin of the field will be given by, so what is that charge? That is you have to find. This is the simple question and you have to apply Gauss's theorem. What is Gauss theorem? In electrostatics, it says that the flux coming out from the Gaussian surface is equal to the charge enclosed by that Gaussian surface divided by the epsilon naught. This is your Gauss theorem. Okay. This is the total flux passing through the Gaussian surface, and this is the net charge enclosed. If I consider this radius A and this sphere of radius A as my Gaussian surface, and I apply Gauss theorem, then the flux that is coming out, of this closed surface is equal to the total charge that I have taken here, that is Q, divided by epsilon naught. And what is that flux? Flux is a dot product of E dot ds. Okay, closed surface, Q upon epsilon naught. So from here I can write that Q, the total charge enclosed within the Gaussian surface. Obviously that charge is concentrated at the center, but then Q is given by E dot ds integration dot is a vector and epsilon naught. This is epsilon naught. E is how much? If I have charge over here, the electric field is extending radially and at a distance A only. A. What is the electric field at A? Electric field at a distance A will be equals to A into A, because E is a function of AR. So depending on the position, this is R equals to A, so it is AA. This is 0, so dot cos 0 is 1, and ds you write what is the area of this Gaussian surface. This is sphere of radius A, so that is 4 pi A square. So this is the answer to this question, that is equal to 4 pi epsilon naught capital A and A of Q. So this is the charge which is present at the center of the sphere. So if I see the option, then 4 pi epsilon naught AAQ, 4 pi epsilon naught AAQ. So this is the correct answer to this question. Okay, thank you.